short introduction to the idea of coterminal angles and putting angles in standard position. So we're thinking about angles on the circle, and there's two reasons we could do that. We could be looking at the geometry, sort of like, let's say we have a slice of pizza and we want to know how much pizza we have, and we're thinking about the angle here, like for example this is a 45-degree angle, as a measure of how much of the pizza. That's certainly interesting. But the other thing, and the thing that we actually started with in our investigations, was rotation. And so we could actually think of this as something moving on a circle. So it starts here and it rotates around and around, and let's say it started here, and if it ended here, when we could say it rotated, this point has rotated around the circle by 45 degrees worth of rotation. And it's that idea of rotation that's actually more general, and that has to do with the idea of coterminal angles. The first thing to say is that whenever possible, we are going to have the positive x-axis all the way to the right of the circle as our standard starting point. So that's going to be 0 degrees. And then this would be 45 degrees. Then this would be 90 degrees of rotation. This would be 180 degrees, etc. But the interesting thing about rotation is that you can go all the way around the circle. So this 45 degrees, suppose I know that the point is here, or maybe this is like a spoke of the wheel, and it started in this position, and then I close my eyes for a minute, and then I see that it ended up here. Well, it could have done this, going from here just to here, just 45 degrees worth of rotation. But it also could have gone all the way around 360 degrees plus another 45 degrees. So this guy could be 45 degrees, or could be 360 plus 45 is 405 degrees. And that's going to be two different amounts of rotation producing the same final state, the same final place where the thing could have ended up. And so these guys are called coterminal angles. Let me see if I can make this a little bigger. Yeah, there we go. These are coterminal. Coterminal means that terminal means, you know, the last place. And so we're thinking of this as something's rotating, and the initial place it was at 0, and the 45 degrees of rotation and the 405 degrees of rotation share the same ending point on the circle, the same terminal point of the rotation, and so they're called coterminal. Now we could also do that in radians. That's going to be, oh, I need this guy. 45 degrees. If I multiply that by pi over 180, then I get pi over 4. Or if I add 2 pi, which is 1 full revolution, I get 9 pi over 4, because 8 pi over 4 is going to be one way to say 2 pi. So those guys are going to be coterminal. And there's many more. I could revolve twice around. I could add another 8 pi over 4, so I could actually say, or 17 pi over 4. There's going to be an infinite number of angles, of amounts of rotation that are going to be coterminal. Now sometimes we care about the difference because we're actually thinking about how long did it take to do something, how fast is it rotating. Other times we're going to just care about where we end up, and so we're going to think of these as basically the same. They label the same point on the unit circle. But it's going to be a subtle distinction as to when we care about the difference and when we don't. So it's good to get this out right now, but it's definitely not the last time we're going to see it. We could have even done this by starting here and revolving backwards. And our convention is going to be that counterclockwise rotation, like this, is positive. Let me write that down. Counterclockwise rotation is positive, and clockwise is negative. It's just the standard mathematical convention. Okay. And so is there a clockwise rotation, a negative rotation that could have ended up here? Yeah, we could have gone around almost all 360 minus 45 degrees. So this is going to be another thing we could add to the list. And so this could also be seen as, it's also minus 315 degrees, Or, of course, what's that in radians? Well, it's 2 pi. Oh, except I didn't go all the way to 2 pi. I didn't do the last pi over 4. So 8 pi over 4 minus pi over 4. So I did the backwards direction minus 7 pi over 4. So those guys are also coterminal with pi over 4. All these things are different ways to describe this one point on the circle. You might not have thought there's so many ways to describe this one point on the unit circle, but there's many, many ways. Radians and degrees, and also all the different coterminal angles. So there are different ways to rotate to the same place. And the idea, I just did one example, but the idea in general is we can always add or subtract any multiple. Let me make that a little wider. Of 360 degrees, if we're in degrees, or 2 pi radians. And notice when I have these angles, I didn't put the word radian, because if we put an angle without any descriptor, without a little degree symbol, we should always mean radians. Even if it doesn't have a pi in it. The pi is a kind of a giveaway that we're probably mean radians, but even if I said 3.7, it should mean radians. Okay, but I'll put radians here to make it clear. So you can always add or subtract any multiple of 360 or 2 pi radians to produce a coterminal angle, and you'll have some problems about that. That's good.